All right, so like you just told me, you have an isosceles triangle. Two congruent sides are going to have two congruent angles, so we'll talk about which ones those are in a minute. But in order to address the sides and the angles that are the same or different, you got to know what they're called, okay? Does anyone think they know what the two congruent sides are called? It's a body part. Yeah, Michael. They're the legs. Yeah, these are the legs of your isosceles triangle. Okay, so two congruent sides are called legs. The angle where your two legs meet up, any idea what that angle is called? Not the head. It's your vertex angle, okay? So this angle right here is called the vertex angle. The vertex angle, okay? The side that is across from the vertex angle, so the side that is not one of your legs, anyone know what that's called? Right now it looks like the bottom. What do we sometimes call the bottom of something?
Base?
Yeah, the base. Cheerleaders in the room know what I'm talking about, right? So the side opposite the vertex angle is called your base. So this side here would be the base. Okay, so that makes those two angles that are touching the base. Any thoughts? Those are called your base angles. Okay, so this angle right here and this angle right here, those are base angles. Okay, so if I talk about the vertex angle ever, I'm talking about the angle between the two congruent sides. If I talk about the base angles, I'm talking about the two angles that are touching your two congruent sides, but not between the two congruent sides, okay? Okay, two theorems that come into play here, and we already talked about them, so this should make perfect sense. The one says if two sides of a triangle are congruent. In other words, if a triangle is what? If two sides are congruent, what do we call that? Isosceles. So if a triangle is an isosceles triangle, then the angles opposite those sides are congruent. So in other words, in this picture, we would say the measure of angle 2 is equal to the measure of angle 3. Or you could say the angle's opposite. Yes, that angle A is congruent to angle C. Okay, so their measures are the same. They are congruent angles. Okay, the converse says if the angles are congruent, so sometimes they're going to give you a picture where all you know is those are congruent. If you know that, you are able to say, well, because those angles are congruent, then the sides across from them have to be congruent too. Okay, so in this picture, it's basically saying if angle A is congruent to angle C, then AB will be congruent to BC. Okay, so it's a converse and an original theorem that are both going to be true always. Okay, so take a look at this first picture. Have they told us that this is an isosceles triangle?
Yes.
How?
The like marking.
Your markings. Okay, so these markings say those are congruent. And if those are congruent, then base angles have to be congruent as well. So which two angles are congruent right now? J and L. These two angles will be congruent. So the measure of angle J is 68. How do you find the measure of angle K? Yeah, subtract from 180. So if this is 68, 68 and 68, and the measure of angle K have to add up to 180. So subtract, what is that, 136? So the measure of angle K is going to be 44 degrees. Right? You're just taking this away. Okay, so on that one, they gave us a base angle. What'd they give you on number 2? Yeah, name it. What's it called? The vertex angle. Okay, so if they gave you the vertex angle, you're missing the 2 that are congruent. Simon.
Can you subtract 106 from 180?
Mm-hmm.
Split it in half.
And then cut it in half. Yeah. If that doesn't make sense to you, give this a variable. If this is x, then what is angle E? X, right? If you want to call them both x, then you can say x plus x, or 2x plus that 106 should equal 180. Take away the 106, and you get 74. And then divide by 2. What do you get? 37, right? That means both of those are 37. So C is 37 degrees and E is 37 degrees. The most common mistake I see made on problems like this is everyone wants to treat it either like this type of triangle every single time or like this type of triangle every single time. You can't. You have to pay attention. Did they give me the vertex angle or did they give me a base angle? Okay, and then work from there. Okay. Look at number 3. Can you tell me how long this is? 12 centimeters. If your base angles are congruent, then the sides across from them have to be congruent. So this is 12 centimeters. And then y you would just subtract from 180, right? 180 minus 77 minus 77. We're not even going to do that right now. Okay, look at ones like 4 and 5 here. Tell me how you can solve for x. Set them equal. Those are base angles. This is your vertex angle. That one's not equal, but across from the congruent sides are the congruent angles. So 5x plus 9 is going to equal 8x minus 30, and then do the algebra, okay? So subtract your 5x and add your 30 and divide by 3. X is 13. Sorry, not degrees. How can you check it? How can you check if that's the right answer? Plug it in to what? Plug it into both. They should be equal. Okay, so if you plug it into both and you get the same measure, then you know you did it right. If you plug it into both and they're different measures, something's wrong. What are you going to do on number 6? Set them equal again, right? Those are congruent sides. The sides across from your congruent angles are your congruent sides. So you would just set those equal. I'm not going to solve that one because you guys are good at the algebra, but just talk through the process. Okay, so those ones you would just set equal. Okay, go to the next page. I highly recommend this happens on your quiz, okay? We don't always give you the picture. Some of you benefit greatly from a picture. So if the picture is not given, I recommend you just draw your own picture and mark what you know, okay? So look at one like number 8. It says in triangle RST, RT is congruent to ST, okay? So if you draw a triangle, I'm going to put T up top. RT is congruent to ST. Okay, I think it's helpful just to see it. Because then you see, okay, well then if angle R is 9x plus 2, you could fill that in. Angle S is 13x minus 18. And angle T is 17x plus 1. Okay, that just gives you a visual. Here's what we're working with. Which two sides are the same, so which two angles are the same. It says find x and then the measure of each angle. What are you going to do with that?
Set
Set
the
on
base
as
is
equal.
You could set the bases equal. Is there something else you could do?
Put them all together and kind of like set it to one.
Totally. So if you wanted to do more work, I don't know why you would, but if you wanted to, or if you didn't see your other option, you could on this one add all three of these up and set it equal to 180. The quicker way is just set these two equal because they are congruent base angles in an isosceles triangle. So you're going to go take away the 9x. You get 4x, add the 18. So you get 20, and then divide by 4. So x is going to be 5. Okay. How do you find r, s, and t? You plug them in. So you're going to go 17 times 5 plus 1 is going to be angle t. And that you can literally just plug into your calculator. That's totally fine. Did anyone do that yet? What do you get? 17 times 5 plus 1. Did you get 86? Hopefully. Same thing with r and s. Plug them both in. 9 times 5, 45 plus 2 is 47. Do you have to plug it into s? What is s going to be? 47. It's going to be the same as r. Now, could you, should you, maybe, just to check your answer, make sure you did it right, but you don't have to. Okay? All right. Take a look at this one. This last thing, an equilateral triangle. What does equilateral mean?
Equal on all sides.
All the sides are equal. What does equiangular mean? All the angles are equal. Okay, so anything that is equilateral is equiangular, and anything that is equiangular is equilateral. It is impossible to make a triangle that has 3 congruent sides where those 3 angles aren't the same. What does that mean about those 3 angles? They're always 60. You don't have to do the math. Every single equilateral triangle has 60-degree angles, okay? Essentially, you're going 180 divided by 3 because all 3 are the same, okay? So what this theorem here says is a triangle is equilateral if and only if it's equiangular. If A is equal to B is equal to C, then AB is congruent to BC is congruent to AC, okay? And if those are all the same length, sorry, I guess I should have said equal, not congruent. Equal, congruent, same thing, right? If they're all the same length, then the measure of angle A will equal the measure of angle B will equal the measure of angle C. Side note, that's always 60. So you do 11, 12, and 13, and then we'll chat about them together. All right, tell me about it. What'd you get for the measure of angle C? 60 degrees, good. That number never changes, you guys. You don't have to do any math. If you see an equilateral triangle, 60, 60, and 60, okay? What's BC? What? 9 feet, okay? If there's labels, label. What's AC? 9 feet, okay? This one, notice they didn't tell you the lengths of the sides, but they did tell you the lengths of the sides. They told you they're all congruent. So they're all 24, which means it's equilateral. What are the measures of those 3 angles? 60. You go 180 divided by 3 is 60 degrees. So 60 and 60 and 60. Okay. What'd you do with this one?
For the outside, you just set them equal to each other, or like just pick 2 and set them equal.
Pick 2, any 2, right? They're all going to be the same length. So pick 2 sides. You can go 9y plus 1 equals 11y minus 23. So take away 9y, add 23, divide by 2. Okay, so you get your y. Y is 12. How do you get x? 7x minus 3 equals 60. Did anyone do it a different way? Did anyone add the 3 up and set it equal to 180? You totally can. I wouldn't. It's more work, right? But you know the 3 angles of a triangle always add up to 180. So if you forget the fact that that has to be 60, you know they're all the same, set them equal to 180, and solve that. But this is definitely the quicker route. 7x minus 3 equals 60. So 7x equals 63. Divide by 7. X equals, what is that? Have you guys ever done the rule of 9s? I was showing this to my algebra class. Do you know this rule?
Yes.
If you take your 7th finger, 1, 2, 3, 4, 5, 6, 7, and put it down, 9, this is the rule of 9s, right? 9 times 7 is 63. Yeah? Isn't that fantastic? 9 times 4 is 36. I love that. So fun. Any questions on that? I would say this is one of the easier lessons in chapter 4. There's not a lot of fancy to it. That's the whole lesson.